This isn't CGI and it isn't an alien spacecraft, this is real. Meet Pan-Saturn's strangest moon. When scientists first saw these images, many couldn't believe their eyes. Some thought it was fake. But Pan is very real and its story is one of the most fascinating mysteries in our solar system. Look at it closely, it resembles nothing like the round moons we've grown used to. Instead, Pan looks like a cosmic ravioli, a walnut, a flying saucer drifting through Saturn's rings. See that strange ridge wrapping around its waist? Scientists estimate it rises a couple of miles high. This equatorial bulge is made of dust and ice particles swept up from Saturn's rings. The end result is a shape unlike anything else we've ever found. Even experienced scientists were shocked. Carolyn Porco, who led Cassini's imaging team, recalled how she first saw Pan's picture on Twitter. She thought it was an artist's conception. Then she realized it was the real image, straight from Cassini. Now here's something surprising. Despite looking like a UFO from science fiction, Pan is tiny. Just 35 kilometers across. About the size of a city. Yet it lives right inside Saturn's rings, not outside them. To visualize this, imagine a moon just the width of a small metro city carving a path through one of the most iconic ring systems in the solar system. That's Pan. Pan's story begins not with discovery by direct sight but with deduction. In 1990, astronomer Mark Showalter was studying photographs taken by Voyager 2 back in 1981. He noticed strange wave patterns inside Saturn's rings. Ripples, almost as if a tiny hidden moon were disturbing the particles. By carefully analyzing these waves, Showalter predicted where the moon must be. Then, by re-examining Voyager images of that region, he spotted a faint dot at the exact right location. That was Pan, revealed 9 years after the photographs were taken. The moon received its name on September 16, 1991. Like many Saturnian moons, Pan drew its name from Greek mythology. Pan, the god of shepherds. And that name is fitting because Pan acts as a true shepherd moon. It occupies the 322-kilometer-wide Encke Gap, one of Saturn's most striking divisions in the rings. As Pan orbits, its gravity clears stray particles, keeping the lane open. Every bit of ring material that drifts into Pan's path gets kicked away with a gravitational nudge. Even the edges of the Encke Gap bear Pan's signature. The inner boundary of the gap has a scalloped pattern, tiny wave-like distortions carved out whenever Pan sweeps by. The moon is constantly gardening Saturn's rings, exerting precise control over the particles around it. Without Pan, the Encke Gap wouldn't exist the way we see it today. How did Pan become this bizarre ravioli-shaped object? The answer lies in its unique environment. Pan orbits at the exact center of the Encke Gap, surrounded by an endless reservoir of ring material. Over millions of years, Pan has swept through this dust and ice, gradually collecting particles along its equator. Imagine starting with a simple, spherical moon. Every orbit, some particles fall onto its equator, sticking to its surface. Over countless cycles, this builds up a giant ridge, circling its waist, the very structure we see today. It's a natural consequence of orbital mechanics and the thin, flat geometry of Saturn's rings. Pan couldn't have inherited this shape at birth. It was sculpted, grain by Saturn's rings themselves. Pan also keeps company with a faint ringlet inside the Encke Gap. This ringlet coincides almost exactly with Pan's orbit, suggesting that Pan both maintains it and interacts with it, locking some particles into horseshoe-shaped paths. Saturn and Pan are, in a sense, co-authors of this unusual cosmic design, and Pan isn't alone in its strange appearance. A few of Saturn's other shepherd moons, like Atlas and Daphnis, also developed equatorial ridges, but none are quite as pronounced or dramatic as Pan. For years, Pan was just a blurry dot. Then in March 2017, NASA's Cassini spacecraft changed everything. During its closest ever encounter, Cassini flew within just 24,600 kilometers of Pan. The spacecraft's cameras revealed Pan in stunning detail. Its ridges, its ridged equator, its craters, and its textured surface, suddenly clear as never before. The images were so surreal, many were shared online captioned as Saturn's UFO. Cassini showed us that Pan's surface wasn't smooth. Its northern and southern hemispheres were cratered and irregular, while the waistline stood tall, piled with dusty ring particles. For the first time, Pan's otherworldly shape and texture could be understood. But beyond the visuals, Cassini also gave us insight into Pan's role as an architect of Saturn's rings. Its gravitational influence is delicate, yet powerful enough to maintain a 200-mile gap against trillions of colliding particles. This tiny moon reminded scientists that even small bodies can control, stabilize, and shape massive planetary systems. Pan's story is a reminder of how complex and dynamic Saturn's rings really are. Far from being static, the rings are alive with movement, particles colliding, moons sculpting, gaps forming and shifting as gravity rewrites the architecture in real time. Pan teaches us about moon formation and accretion. It shows how objects interact through subtle forces, how even tiny moons create massive signatures in ring systems. In planetary science, Pan became a natural laboratory for studying these processes. It also highlights the importance of long-term exploration. Voyager gave us the first clues, dedicated astronomers pieced the puzzle together, and Cassini revealed the moon in breathtaking clarity decades later. And what about the future? Pan is stable for now, shepherding the Encke Gap. But in the far future, ring particles may reshape it once again. Over millions of years, its equatorial ridge could grow, or Pan could become buried in dust. In planetary timescales, even moons evolve before our eyes. Perhaps the most important lesson Pan leaves us with is about perspective. In a solar system filled with giants, Saturn itself, Jupiter, Titan, Ganymede, Pan stands out not for its size but for its strangeness. Just 35 kilometers wide, yet capable of sculpting one of the universe's most recognizable sights. Pan reminds us that greatness is not measured in scale alone. Even the smallest celestial objects can hold secrets that reshape our understanding of the cosmos. And as the Cassini mission has shown, sometimes it takes decades, patience, and persistence before we truly see what's hiding out there. Pan, Saturn's UFO moon, is proof that the universe still has the power to surprise us in the most unexpected ways. Pan changed the way we understand Saturn's rings. What other secrets lie waiting among Saturn's 145 moons? Subscribe and join us as we explore the mysteries of the solar system, one discovery at a time.